Luke, let's read number 1.
Water is dripping out of an inverted cone at the rate of 2 feet cubed per minute. The cone has an altitude of 10 feet and a base with a diameter of 6 feet. When the height of the water in the cone is 3 feet, determine how fast the height of the water is changing.
Okay, let's start by writing out Fuigi. Because when I give you partial credit, I want to be able to see all of it. And as long as the information is relevant, I'm going to give you points on those. So the water is dripping out. So what can we anticipate about our end result of our speed? Is it positive or negative? It's going to be negative. So here's our anticipation. Our answer must be negative at the very end because the water is leaving. All right. How do I know what we are looking for? Find the what? Find is determine the speed of the height. So let's write out F as in Puigi. So I'm going to write out dH over dt, depending on what variable you use. That h might be something else. Okay, do we have when? When what? Height is 3 feet. Now the units do matter because if I all of a sudden make it into inches, you want to be able to convert it into a common language. And then our given rate, which is our given rate? So the water is dripping out of an inverted cone at the rate of, so I'm going to write out G. Now, when the water is disappearing, is that the area, the perimeter, or the volume? The volume. So I'm going to write out dV over dt. And it's dripping out. So I'm going to go ahead and underline or circle the out part. So that's going to be our negative. So 2 feet cubic per minute. And if you didn't know it had to be volume, we had our cubed, which is referring to our volume. All right, for the equation. I know the equation is given right here, but I want to go ahead and elaborate on the area of the base. For a cone, the area of the base is always what shape? Circle. An area of the circle is what? Pi r squared. 2 pi r is the, there you go. So let's write out volume is equal to 1/3, and the base alone is pi r squared in h. And I'm going to analyze the figure. Let's analyze the figure right now and see what's happening. So would you guys agree if I go ahead and complete this triangle compared to the volume of the actual amount that's filled? We have 2 triangles within another. Yeah? So what I want you guys to do is draw 2 triangles, one that's bigger than the other. The first one is the amount that would actually fit. The second one is the amount of water filled in. So let's look at our dimension. We have on here, what amount do I have so far? It says the base with the diameter of 6 feet. If this whole thing is 6 feet, what can I say about just that piece? 3. The altitude is the height of the item. And then the altitude is vertical at all times or perpendicular to the base. So how many was that given to us? 10. And the way I'm going to name this is going to be the following. I have it in terms of r, in terms of h. So let's call this r as in the radius, h as in the height of the value, which is also the altitude. Everyone good on that one? All right. Here's something that I am going to alter. If we find the derivative of this, how many variables do I have? 2. And they're side by side, meaning we have to use product rule, right? I want to avoid that if at all possible, but by writing the proportion. So let's do 3 over 10 is equal to what over what to be consistent? R over h. Now you can either solve for h, solve for r, it doesn't really matter. I think I want to leave this in terms of h, meaning solving for r. So we have 10r is equal to 3h. And then we are going to divide it by 10 on both sides, so we get r is equal to 3h over 10. What that's going to allow us to do is the following. If I plug in what the r is by itself, I have everything in terms of h. So I'm going to rewrite this guy out. We have 1/3 pi, and our r is going to be 3 over 10 h squared times another h. Now, just for teaching purpose, so it doesn't mess you up on the test, I'm going to go ahead and show you every single step after this. So let's start by squaring 3 over 10h. 3 squared is how many? 9. 10 squared is how many? 100. And h squared is simply h squared, and leave the h at the end. It looks pretty messy, so let's go ahead and simplify it further. So I want you guys to look at the following. What is 9 divided by 3?
3.
So let's write out volume is equal to 3 over 100, since I didn't mess with the 100, pi. How many is my new power for the height? Cubed. So now I have one variable, meaning when I find the derivative, it's easier. So if you want to leave it as multiplying or product rule, go for it, but I want to avoid it. So let's write out that formula on the side. So let's find the derivative with respect to t, since we're looking at it with t as in time. So derivative of 1v is basically 1, right? But I don't want to write the 1. Just write out dv over dt. What is the derivative of 3 over 100 pi h cubed? What would that give us? 9 over, because the derivative is to take the power and the coefficient and multiply, over 100 pi h squared. And we have to add dh over what? dt. And let's see what we are actually looking for. My goal is dh over dt, which I have right here. So all I need to do is basically divide it by this guy, correct? Could I now plug in what the h value is basically? Who is my h on the when? 3. So I'm going to make dh by itself already right here. And we know our dv over dt was -2. And I know it looks pretty fancy with fraction over a fraction, and this will be a calculator portion. How many would that be? 3 all squared. So if you have a calculator, type it in with me. If not, make sure I'm not making silly mistakes. So we have -2 on the bottom. Oh, look what I did. Oh, goodness. What do I do? 9 over 100. And yes, use the pi button, because if you have it rounded, my answer might be a little bit different than yours. So let's see what this would be in decimal. First of all, did I get a negative answer, as in it's getting smaller and smaller volume? Yes, I did. And our height is also getting smaller. So we have dh over dt is equal to negative. Okay, someone give me 3 decimal places if you have it. 0.786. And that was feet per minute, because the height is not feet square or any of that, just feet. So when you're reading these word problems, just ask yourself, if it is dripping out, it must be negative. If I'm losing volume, it should also be negative. So add that on there on your own, because I'm not going to put double negatives on the word problem. All right, let's go to our last one, number 2. Mason, let's read.
A truck is pouring gravel onto the ground in a cone-shaped pile. The height of the cone is always twice the radius. The radius is increasing at a rate of 3 inches a second. Find the rate of change of the volume of a cone when the radius is 5 inches.
So let's write out Fuigi. Okay, let's write out what we are looking for. Is there find? Is there determine? Is there what is? Find the which rate? Change in volume. So we have dv over dt. So the truck is pouring gravel onto a ground in a cone-shaped pile. I don't know how the truck would make it into a cone-shaped pile, but let's assume it doesn't get domey. So the more it pours, is it going to increase in volume or lessen in volume? Increase. That'd be talented. Imagine them. I can't. I see a dome and I see a just splatter everywhere, but that's okay. All right. Is there information with when? When? Radius is how many? Again, the unit's very important. In case I give you 2 different units, it has to be common throughout the whole thing. What about the given rate?
dr.
So the rate, someone say dr over dt. is 3 inches per second. And then the equation, I already told you what the shape is going to be. Same equation as the one above. So our volume is equal to 1/3 pi r squared h. Now something interesting was given to us on the question. What information about the height do I know?
Always twice the radius.
So the height is always twice the radius. Could I go ahead and replace that so we have one variable? Yeah? Let's do that. Volume is 1/3 pi r squared times 2r. What's that?
Wouldn't we be able to solve for that early?
You can, yeah, of course. Because if I have two different variables, I would have to use product rule. I don't want to do it. Especially if that height is 2r, I can plug that in. So I have, let's go ahead and combine our coefficients. 1 times 2 is 2. 3 over understood 1 is 3. Pi r cubed. Oops. So now I have one variable that I need to worry about differentiating. So let's write out our volume is equal to 2/3 pi r cubed. Let's find the derivative with respect to t. What is the derivative of 1b? Just dv over dt. Write the 1 if you want. If I take my power and my coefficient and multiply them, what is going to cancel? The 3 is going to cancel, so we have 2 pi r squared, but we have dr over dt. And the nice thing is, what I am looking for is already by itself, so I don't need to worry about dividing across the equal to. Could I plug in the given rate? Yes, I can. Could I also plug in the given radius? Yes, we can. So dv over dt is 2 pi 5 squared times 3. We can do that in our head, right? 25 times 2 times 3? A little bit bigger? Is it a little bit bigger? 50, what's 50 times 3? 150, and then we have pi, inches cubed per second. But if the test said in decimal, and you type this in, it's going to give you 471.239. So really, in the end, just read what the test is going to ask you for. And if it says to multiply out the pi and ask you for a decimal, just multiply them all out. Are we all set? Perfect.